So today we are diving into one of the most critical topics of this particular unit, that is climate change. So to build a strong foundation, we have to examine what climate change actually means. So broadly defining, it actually refers to a long-term shift in global or regional weather patterns, which is marked by some specific parameters like temperature, precipitation, and wind, which is being observed over decades or sometimes to centuries. So we have to pay close attention to the official Intergovernmental Panel on Climate Change, shortly abbreviated as IPCC, which defines that climate change refers to a change in the state of the climate that can be identified by shift in the mean or variability of its properties and that persists for an extended period, typically decades or longer. So you have to keep this in mind because sometimes UGC NET often tests your direct conceptual framework. So please remember this definition. So in the right corner of this particular slide, there is a particular box in the quotation written, forget me not. So here I have highlighted the differences between weather and climate. So weather basically represents the day-to-day or short-term atmospheric conditions. For example, today's rain or today's temperature. While climate represents the long-term statistical average of atmospheric patterns which is being observed over extended periods. So typically it is 30 years according to the World Meteorological Organization. So below, I have divided the causes of climate changes into two broad categories. Number one is the natural causes and number B is the man-made or anthropogenic causes. So let us now delve into the natural causes, and the number one is Milankovitch cycle. So it is basically the Earth's orbital variation, be it the axial tilt and precession and sometimes eccentricity, which affect how solar radiation is distributed across the planet over 10 of thousands of years. And secondly, we have the volcanic eruptions. So we all know that the major eruptions or the volcanic eruptions release a large number of sulfur dioxide, which we commonly known as SO2, and aerosols into the stratosphere, which temporarily cool the planet by reflecting sunlight through volcanic carbon dioxide also contributes slightly to atmospheric carbon. Thirdly, we have solar radiation variability. So it basically refers to the changes in solar intensity and sunspot cycles that alter the total radiation Earth actually receives. Number four, we have the ocean currents and ENSO. So phenomena like the El Nino Southern Oscillation, which we abbreviated as ENSO, that alter global heat redistribution between ocean and atmosphere. In the right side, we have the anthropogenic or human-induced causes. Number one is definitely the greenhouse gas emission. So the burning of fossil fuels for power and transport increases concentration of carbon dioxide, CH4 and N2O that actually enhances the natural greenhouse gas effect. Secondly, we have the deforestation and the land use change. So it basically refers to the clearing of forests that remove the carbon sink while releasing stored back carbon back into the atmosphere. And thirdly, we have the industrial and agricultural activities. So we should know that industrial manufacturing releases a large number of synthetic gases like chlorofluorocarbon, hydrofluorocarbon, and SF6, while agriculture releases significant methane, especially in paddy fields, livestock, and nutrients in terms of the usage of fertilizers. So at the below of this particular slide, I have defined the measures to control or to mitigate this particular sort of climate changes. So firstly, that is the transition to renewable energy. So we have to shift our attention from coal and oil to another energy forms like the solar, wind, hydro, and geothermal energy to decarbonize the power generation. Secondly, we have the afforestation, reforestation, and forest conservation. So afforestation refers to the planting of new forests, while reforestation refers to restoring the damaged one to actively sequester atmospheric carbon. And thirdly, we have the energy efficiency, so which basically refers to the enhancing operational efficiency across industrial processes and building designs and clean public transportation system. So with this, we will move to the slide number 2. In slide number 2, we will see the resources and their broad classification. So first, what constitutes a resource? So we all are well equipped with the definition that resource is any material, element, or energy source present in the environment that possesses utility. We have to remember the particular term utility, and it satisfies the human needs. However, from an academic and environmental perspective, and this is a favorite and net topic, that a material does not automatically become a resource simply by existing. An element has to become a particular resource only when human society possesses three crucial prerequisites. Number one is the technical accessibility. So in order that we have to have the knowledge and tools to extract or harness it. Secondly, we should have the economic feasibility. So the cost of extraction and processing must yield a viable economic benefit. And thirdly, we should have the cultural acceptance. That means society must accept its utilization as appropriate and beneficial for the society. Now, should look at the types of resources which is being divided under various norms. So firstly, we have to look at the based on origin. There are two types of resources. Number one is the biotic resources, which is simply referred to as the living resources. And number two is the abiotic resources, that is the non-living one. So the biotic resources, it is mostly derived from the biosphere and the possess life. So it basically includes the flora, the fauna, the livestock, and as well as the fossil fuels. So which originate from the decayed organic matter. And secondly, we have the abiotic resources, which is mostly comprising of the non-living inorganic matter. So please define it. One is the organic, that is the biotic resources, and the inorganic is the ones that is related to abiotic resources. So it mostly includes the land, water, air, rocks, and metallic or non-metallic minerals. So based on exhaustibility and replenishment, we have two types of resources. One is the renewable and another is the non-renewable. So renewable, the other term for the renewable resources is inexhaustible. So that resources that can be naturally replenished or regenerated over short periods faster than their consumption rates are termed as renewable or inexhaustible resources. So here examples could be solar energy, wind energy, tidal energy, and biomass. Next, we have the non-renewable resources, which is exhaustible in nature. So these are the resources that actually exist in fixed quantities and take millions of years to form through geological processes. So once it is being consumed, they cannot be quickly replaced. So here we are already familiar with the resources like coal, crude oil, natural gas, and mineral ores. So based on ownership, we have four types of resources. One is the individual, second is the community, third is the national, and fourth is the international. So individual resources, as the name defines, it is owned privately by individuals. For example, our own house, our private land, or our personal wealth that is being attached to our homes. Secondly, we have the community resources, so which is accessible to all the members of a specific community. For example, we can have the village pond, public parks, or the grazing grounds. Thirdly, we have the natural resources. So technically, we can say that all resources within a country's territorial boundary and exclusive economic zone up to 12 nautical miles from the coast belong to the nation. And fourthly, we have the international resources, which are the oceanic and atmospheric resources that are measured beyond national territorial waters, and EEZ that I have already tell about exclusive economic zones. So here we can take the example of the open ocean waters that is being managed by the international treaties like the UN Convention on the Law of the Sea. Now, moving on to the slide 3, we have the constituent of greenhouse gases. So, in order to understand the greenhouse gases in depth, we must categorize them based on their origin, and in two groups. Number one is the naturally occurring greenhouse gases, and secondly are the synthetic or the industrial gases. So in naturally occurring greenhouse gases, firstly we have the water vapor. That is the most abundant greenhouse gas overall. Secondly, we have the carbon dioxide, CO2. That is the primary driver of human-induced climate change. Fourthly, we have methane, which we known as CH4. So though it is short-lived but highly potent greenhouse gases. Number 4, we have nitrous oxide, N2O. So it is a long-lived gas primarily linked to agriculture. Please mark this thing. Number one is the methane, though it is short-lived, but it is highly potent, and nitrous oxide, though it is long-lived, but it is specifically related to agriculture. And lastly, in this particular category, we have the ozone, that is O3. So we already have discussed that there are two types of ozone, that is the tropospheric ozone, and number second is the stratospheric ozone. So the tropospheric ozone acts as a significant greenhouse gas. However, the stratospheric ozone, as we have already discussed, it is act like a shield against the harmful ultraviolet rays. Secondly, the classification is about synthetic or the industrial gases, and here we have the first example of hydrofluorocarbon, HFCs. So commonly it is being found in the refrigerators, so it is managed globally under the Kigali Agreement to the Montreal Protocols, which we will be discussing in our later discussion part. Next we have perfluorocarbon. So it is emitted during aluminum production and semiconductor manufacturing. Number third, we have sulfur hexafluoride, SF6. So it is mostly used in electrical power transmission equipment, and it holds an extremely high global warming potential. And number 4, we have the nitrogen trifluoride, NF3, which is primarily generated during microelectronics and flat panel display manufacturing. So below we have the quick summary table where you can remember all the gases, their formulas, and their primary source and their impact within the particular domain of climate. So we will now move to slide number 4, which is all about the forest resources. And we all know that forests are like the lungs of the planet. So it is an essential component of natural resources, which is being frequently examined in UGC NET exam every now and then. So before analyzing the classification, we have to note the official definition, which is being derived from the Interstate of Forest Report. So if we see the next slide, so here is the particular definition that I would be reading out for you. So all lands with a tree canopy density of more than 10% over an area of 1 hectare or more, irrespective of land ownership or tree species, which could include orchid, bamboo, palms. And remember this 10% density and 1 hectare threshold, because sometimes the objective questions being framed around this only. So please remember, in order to identify a particular sort of geographical location as a forest, we should have the 10% density of the tree coverage and 1 hectare threshold. So in order to not miss out all the match the following or statement based question. So we have the classification or types of forests mostly found in India. So number 1 is the moist tropical forest. So we all know that the tropical wet evergreen forest where we receive the rainfall less than 250 centimeter. So it is mostly dense, multi-layered canopy where leaves do not shed simultaneously. So its feature could include mahogany, rosewood, ebony in Western Ghats and Andaman and Nicobar Islands, and as well as in the Northeast as well. Nextly, we have the tropical semi-evergreen where it receives the rainfall of 200 to 250 centimeter. So these are the transitional zone between wet evergreen and deciduous forest. So please remember this, that the tropical semi-evergreen forests are the ones that actually links between wet evergreen and deciduous forest. And here the features could include white cedar, Indian rosewood in Assam, Meghalaya and Western Ghats as well. Thirdly, we have the tropical moist deciduous forest where we receive the rainfall of 100 to 200 centimeter. So here, the trees shed leaves for 6 to 8 weeks in spring or early summer. So the dominant species include here would be teal, teak, sal, sisam, sandalwood across the Chotanagpur Plateau and Himalayan foothills as well. And fourth, we have the littoral and the swamp, which we can mostly find in the saline coastal areas. So the soil tolerant halophytes with nemophores, and it could features the species like mangroves, Sundari in Sundarban Delta, Mahanadi and Godavari deltas as well. Next, we have the tropical dry deciduous forest. So it is the most widespread forest type in India. Please mark that. And here the features could include teak, axlewood, tendu, neem across the plains of UP, Bihar, Madhya Pradesh, Maharashtra and Tamil Nadu. Next, we have the tropical thorn forest. So we all know, like hearing the particular term called thorn, where we receive rainfall less than 50%. So the xerophytic vegetation with deep roots, thick bark, and spiny leaves. So here the features could include acacia, kher, cacti, palms across Rajasthan, Gujarat, and the semi-arid Deccan Plateau. Next, we have the tropical dry evergreen forest where we receive the rainfall of 100 centimeter, that is mostly from the monsoon rain. So it is the short, dense evergreen trees with limited distribution, and the here features of the species could include jamun, cocoa, neem, toddy palm along the Coromandel coast. Next, we have the subtropical broad-leafed hill. So here we receive the rainfall of 150 to 300 centimeter. So here the evergreen species with common epiphyte and fern growth. We all have come across the particular term called fern and its look as well. So here the features could include oaks, chestnut in eastern Himalayas, Nilgiri and Palani hills. Then we have the subtropical pine, where the rainfall is about 100 to 200 centimeter. So it is the pure stands of resin producing pine trees. So please remember that the resin. It is dominated by pine, Chirpune in western and central Himalayas. Next, we have the subtropical dry evergreen forest. So it is the low, the shrubby evergreen trees and thorny bushes. And here the features could include wild olive, Kulai in Bhabar, foothills of Shivalik and western Himalayas. Then we have the mountain wet temperate. So it is also known as the sholas in South India, evergreen short trees. So here the features could include deodar, oak, magnolia, laurel in Nilgiris, Annamalai, Palani Hills and Sikkim as well. Next, we have the Himalayan moist temperature where the rainfall is about 150 to 250 centimeter. So it is the basic feature of coniferous forest with soft wood trees of high commercial values. So here could the featuring species could include deodar, blue pine, silver fir, spruce in Kashmir, Himachal, Uttarakhand and Sikkim. That is mostly in the Himalayan regions. Next, we have the Himalayan dry temperate that there where the place is almost about snowy in nature. So here also we have the coniferous vegetation with sparse undergrowth in dry areas. So here the features could include pine, deodar, willow and juniper in Lahaul, Spiti, Ladakh and inner dry Himalayan valleys. Next, we have the subalpine forest. So it is the upper limit of tree growth. So the features could include silver fir, birch, and in high Himalayan areas. So you have to remember that it is mostly found at the upper part of the trees. Next, we have the moist alpine shrub. So it is the low evergreen dense growth of dwarf trees and shrubs. And here the features include black juniper, dwarf mosses at high altitudes above timberline. And lastly, we have the dry alpine shrub, which is the xerophytic dwarf shrub, cold desert conditions. And here the features could include ephedra, juniper in cold deserts of Ladakh and Trans Himalayas. So with this, we will now move on to the next slide, in which we will be discussing about the major acts and legal frameworks governing forest conservation and environmental protection in particularly India. So questions from this topic frequently test the years of enactment, constitutional roots, statutory bodies that were being created, and key objectives. So let us break down each landmark piece of legislation chronologically. So first, your first task would be to remember it chronologically, because sometimes UGC NET frames the questions in such a way where you have to arrange all these acts or legal frameworks in their chronological order, and it is better to remember the years as well with their main objective. So number one, we have the Indian Forest Act in the year 1927. So coming to the background, we can see that it is a colonial era consolidation framework enacted to regulate timber transit, collect revenue on forest produce, and establish state control over forest land. So here the key provisions, if I go on to discussing, so it is categorized forest into three structural tiers. Number one is the reserve forest, number two is the protected forest, and number three is the village forest. So all these structural tiers are closely tied to the first act, that is the Indian Forest Act of 1927. Next, we have the Forest Conservation Act of 1980. So if we go on to the background, as we can see the here, it is the post-independence legislation enacted to curb rapid and unchecked deforestation across various states. So coming to its key provision, we can say that a prior permission or approval from the central government before any state or any particular authority can divert forest land for non-forest purpose, such for mining, hydroelectric dams, roads, or any other industrial projects. They have to take permission from the central government. So number third, we have the Environmental Protection Act, EPA 1986. So it is also known as an umbrella legislation because it was being enacted under Article 253 of the Indian Constitution in direct response to the 1984 Bhopal gas tragedy. So please remember this particular Environmental Protection Act because it is being linked to one of the most disastrous event in our own history, that is 1984 Bhopal gas tragedy. So here it empowers the central government to take comprehensive measures to protect and as well as improve environmental quality. Number four, we have the Biological Diversity Act of 2002. So it is being enacted to fulfill India's commitment under the UN Convention on Biological Diversity signed at the 1992 Earth Summit, so which was being held at Rio de Janeiro. So it establishes a decentralized three-tier institutional framework. Number one is the National Biodiversity Authority. Number second is the State Biodiversity Board. And number third is the Biodiversity Management Committee. So you have to remember this three-tier institutional framework. Number five, we have the Scheduled Tribes and Other Traditional Forest Dwellers Recognition of Forest Right Act 2006. So it is one of the landmark social justice legislation which aims to protect and correcting historical injustices committed against forest dwelling communities whose rights were unrecorded during colonial and as well as post-independence forest reserve declaration. So coming to the key provision, you should remember that it recognizes and vests individual rights and community rights as well. So it mostly empowers the Gram Sabha as the primary statutory authority to initiate and determine the nature and extent of forest rights and conservation decisions. Next, we will move to the next slide, which is mostly about the key national policies and initiatives, that is for the forest management in India. So understanding these policies is essential because UGC NET frequently tests specific targets, historical years, and structural distinction between participatory government models. So here I will be detailing about that. Number A is the National Forest Policy NFP 1988. So its core target is to envisage maintaining a minimum of 33% of India's total geographical area under forest or tree cover to ensure ecological balance. You have to remember the particular percentage, that is 33. So it also mandates a higher target of 66% forest or tree cover for hill and mountainous regions to prevent soil erosion and land degradation. And then we have shifted the focus of forestry from commercial timber extraction to conservation, environmental stability, and local community involvement. So it pioneered the concept of joint forest management. And number B, we have the joint forest management and social forestry. It is a term, the social forestry is a term which was being coined in 1976. So please remember the particular year. So the concept is that the joint forest management involves raising trees on non-forest, uncultivated or degraded lands outside traditional forest areas. For example, farm forestry, urban forestry, and community forestry. And its objective is to satisfy local needs for fuel, fodder, and timber while reducing human pressure on natural unreserved forest. And we can also see that there is the concept of joint forest management, which is a concept of co-management partnership between state forest department and local village institution to protect and regenerate degraded forest lands. So here communities protected forest in exchange for non-timber forest produce, NTFP access, and a share of revenue from timber harvest. And next we have to remember the forest right context, which was in the year 2006. So it mostly bridges the statutory governance with community rights by safeguarding the access rights of forest dwelling communities to conserve forest sustainably alongside the state authorities. And next, in the slide number 7, we will be seeing about forest conservation movements in India. So we have already come across this Narmada Bachao Andolan, Bishnoi movement, and etc. So here we will be discussing it chronologically. So moving on to the next slide, we will be seeing that the detailed script of environmental movements. Number 1 is the Bishnoi movement. So your task is to remember the year and the pioneer leaders who were being involved in the particular short-term movements. Number 1 is the Bishnoi movement of 1730, and its region is like Rajasthan, Khejarli village, and the key leader is Amrita Devi Bishnoi. And its primary focus is to protect sacred khejuri trees from being felled by the Maharaja of Jodhpur soldiers, where 363 Bishnoi sacrificed their lives. So all the moments are here being in the chronological order, so you have to remember it chronologically. Secondly, we have the Chipko moment, that is in 1973. So the region is Uttarakhand Garhwal region. So the key leaders here are Sundarlal Bahuguna, Chandi Prasad Bhatt, and Gaura Devi. So the primary focus is to hug the trees to stop commercial logging in the Himalayas and preserve fragile mountain ecosystem. Number 3 is the Silent Valley movement in 1973, and its region is Kerala, Palakkad district. So the key group members here are from the Kerala Sastra Sahitya Parishad. So its primary focus is to prevent the submergence of pristine, moist, evergreen tropical forests by a hydroelectric project over the Kunti Puja river. And number 4, we have the Jungle Bachao Andolan of 1980s, which region is the Jharkhand, formerly part of Bihar, Shingbhum region. So its key group leaders are the local tribal communities, and the primary focus is to oppose the government decision to replace natural sal forest with high-value commercial teak monoculture. And number 5, we have the Apico movement of 1983, and the region is the Karnataka, Uttara Kannada region, that is Karnataka, and its key leader is Panduram Hegde. So it is mostly being inspired by the forest movement, that is the Chipko, and here with Apico means to hug in Kannada. So it aimed at hugging trees to protect Western Ghats forest against commercial clear felling. Next, coming on to the slide, we will see the soil profile. So you have to remember the horizons and the key characteristics. So what is a soil profile? So a soil profile is a vertical section of the soil that mostly displays its distinct horizontal layers, also known as the soil horizon. So each horizon differs in physical texture, chemical composition, color, and biological activity. So for the UGC NET exam, mastering the specific terminology associated with each horizon, such as the alluviation versus alluviated zones, is essential. So we will be breakdowning all the soil horizons. Number one is the O horizon. So please remember that it is the organic layer or the humus level. So it is mostly composed of surface organic litters such as decomposed leaves, twigs, and plant matter. So therefore, it is rich in humus, which gives the topsoil its fertility and water retention capacity. Next, we have the A horizon, which is the topsoil, or we all know as the leaching zone. So it is the uppermost mineral layer enriched with organic material. So it is also known primarily as the leaching zone, where the soluble minerals and nutrients dissolve in water and move downward. Next, we have the E horizon, that is alluviation zone, not I1, that is the alluviation zone. So it is being characterized as the alluviation zone, where E stands for exit. So it experiences significant loss of clay, minerals, silica, and iron oxides, resulting in a lighter bleach appearance. Next, we have the B horizon, which we also known as the subsoil zone. So it is also known as the alluviation zone. So it accumulates the fine minerals, iron compounds, aluminiums, and clays that leach down from the overlying A and E horizons. Next, we have the C horizon. So it is the weathered parent rock. So it mostly consists of the partially broken weathered parent material and regolith. So it contains little to no organic matter and represents the transition layer between the true soil and the unweathered rock. And lastly, we have the R horizon, which is the unweathered bedrock. So it is the solid or the unweathered base rock layer lying beneath the soil profile. So you have to remember it chronology, that number O is the one that is at the top notch level, and R is the one that lies at the beneath or at the base of the soil profile. And you, along with this, you have to remember the key characteristics as well for the soil profile section. In slide number 9, we will be discussing about the major soil groups that is mostly found in India. And this particular soil division is being classified according to the Indian Council of Agricultural Research. So sometimes UGC NET frequently test about the soil classification based on percentage, coverage, chemical composition, mineral deficiencies, and regional nomenclature. So you have to remember these individual characteristics for each soil classification. So in the next slide, you will be seeing all the classification, 8 classification of soil division in India. Number 1 is the alluvial soil. So we all have come across oily soil groups in our foundational school or primary classes as well. So we will be seeing at this. So number 1 is the alluvial soil. So it is mostly formed by deposited by major river systems. And major river systems are none other than the specifically the Indus, the Ganga, and the Brahmaputra, as well as the coastal streams as well. So if you go at the chemical profile, you will be seeing that it is rich in potash and lime, and deficient in nitrogen, phosphorus, and humus. So your task is to remember the chemical profile very clearly. For example, the particular soil, that is the alluvial soil, is rich in potash and lime, but is deficient in nitrogen, phosphorus, and humus. So you have to remember all these. Next, we have the black soil, or also known as the regur soil. So it is mostly formed from volcanic lava flows, predominantly in the Deccan Trap region. So if we go on to the chemical profile, it is rich in iron, lime, calcium, potash, and magnesium, but deficient in nitrogen, phosphorus, and organic matter. Thirdly, we have the red or the yellow soil. So it is developed on ancient crystalline granite and metamorphic rocks in areas of low rainfall. So here the deficient is again nitrogen, phosphorus, and humus. So we should also know that the red color is due to the wide diffusion of iron in crystalline and metamorphic rocks, and it turns yellow when hydrated. Number 4, we have the laterite soil. So it is formed in tropical areas that experiences internal leaching due to alternating wet and dry spells with high temperatures. So Here the silica is leached away, leaving behind high concentration of iron and aluminum oxide. So here this particular laterite soil is rich in iron and aluminum oxide, but silica is being leached away. Next, number 5, we have the arid or the desert soil. So we all know that it is mostly the soil content here is very high. It is sandy in texture and the level of moisture or the humus is very low. So it is predominantly found in arid regions like Rajasthan, and it becomes productive with adequate irrigation only. Number 6, we have the alkaline or the saline soils. So it is also locally known as the Ushar, Kalar, Ray, and Chopin. So the causes for the formation of saline or alkaline soil is the poor drainage, high water tables, and excessive capillary action in dry regions. So coming to the chemical profile, it contains the excess that is abundant in sodium, potassium, and magnesium soil. So therefore, it makes it unfertile for the crop growth and production. Number 7 is the forest or the mountain soil. So it is mostly heterogeneous, acidic with low humus content in snowbound areas, but it is rich in organic matter in lower valley regions. And number 8, that is the peaty and marshy soil. So it is mostly black, heavy and highly acidic soils, and it is formed in the humid areas with dense vegetation. And coming to the key details, so here contains the high amount of soluble soils and organic matter, and it is mostly found in the coastal areas of Kerala, Orissa, and West Bengal. So we will move on to the next slide, where we will be discussing about the global water breakdown, which is a very classical quantitative topic in UGC NET paper 1 under the particular topic of water resources. So in the next slide, you will see that there are the specific percentages in descending order or statement verification questions. So firstly, we will be going at the global water distribution. So in the next slide, we can see that the saline water consists of 97.5%. So we all know that out of 100%, that is saline water alone consists of 97.5%, and it covers the vast majority of Earth's water that resides in oceans and seas, making it very unfit for daily consumption like drinking and watering the plants also. So therefore it is rendered unfit for human direct consumption or agricultural processes because of the presence of high salinity, that is the presence of soil. And in the name of fresh water, we have 2.5% left. So only a tiny fraction out of 100 of the planet's total water volume is fresh, supporting all the terrestrial life and human needs. So again, we all know that the particular freshwater, which is being like volume of 2.5%, it is not available for us to take it directly. So if we go on to the breakdown of 2.5% freshwater also, here about 68.7% is being located to the glaciers and ice cap. So it represents the Earth's largest overall freshwater store. So it is locked away in solid form only, which is primarily found in the regions like Antarctica, Greenland, and high altitude mountain ranges such as the Himalayas. And in the groundwater, we have 30.1%, which represents the Earth's accessible liquid freshwater store. So it is mostly stored at the beneath of the earth's surface in aquifers, which is very vital for drinking, agricultural irrigation, and sustaining river ecosystem. And the surface or the other freshwater that is being composed of 1.2%, and it includes the lakes, rivers, reservoirs, soil moisture, atmospheric water vapor, and biological water as well. And it represents, if you go on to represent in a pie chart, we will be seeing that it represents the very small share, and then also it remains the most visible, accessible, and directly utilized water resource for human civilization. So moving on to the next slide, we will be seeing the types of soil erosion, where the main factor or the main factor behind this type of soil pollution, soil erosion is none other than the water. So therefore, I have mentioned is the water-induced soil mechanism. So
And
in
no
UGC NET
slide
exam,
is seen.
hello.
Well, no slide is seen. Please check.
Wait, there is a technical problem, I think. So I request you to move on to the next slide. Okay, I think there is a technical glitch from the other side. So once it is being resolved, you'll be able to see the breakdown of the global water coverage. So next we have the types of soil erosion where we can have the water induced erosion mechanism. So we have to remember the particular terms along with their meanings. So number one is the splash erosion. Just a second. So this is particularly the initial stage of water erosion. Yeah, this is the one that I have already discussed, that is the global water breakdown. So you can see how this is being framed. And next we have the types of soil erosion, and I have clearly marked where water acts as the major mechanism. Number one is the splash erosion. So here you can see that the initial stage of water erosion occurring when falling raindrops strike exposed bare soil directly, and its impact is that the kinetic energy of the impact dislodges individual solid particles, scattering them and breaking down soil aggregates, as you can directly see in the picture as well. Next we have the sheet erosion. So it occurs as overland water runoff flows evenly over smooth, flat or gently sloping land. So it impact, it can be seen in the picture as well, that it uniformly stripes away a thin continuous layer of nutrient rich topsoil across a broad area. So it is also sometimes net ask you with the another alternate term, that is the creeping debt or the most harmful type of erosion, because it happens so gradually and uniformly that even the farmers often fail to notice the loss until soil fertility is being severely compromised. And number third, we can see that it's a real erosion. So as you can closely see in the picture, it is the surface runoff concentrates into faster streams. Water curves are tiny, distinct channels into the soil, and its impact is that it produces small finger-like micro channels. So these reels are small enough that standard agricultural tillage and plowing equipment can easily smooth them over. And number four, we have the gully erosion. So it is the, as you can see in the picture, it is totally uncontrollable in nature, and it is the uncontrolled real erosion that progresses over time as runoff volume and velocity increases, and deepening and widening the channels into massive ravines. So if you go on to the impact, you can see that it creates a deep trenches and severely dissects agricultural land into in between there is a wide gap, rendering it completely uncultivable. So if you see the types of soil erosion, you have to remember this all four, and you have to remember that here the water is the one that acts as the primary mechanism. And next we'll be moving around to the key water policies, schemes, and bodies in India. So sometimes UGC NET asks the questions framing about the years of its implementation and the key focus. So you have to remember it again chronologically. Number one, we have the Central Groundwater Authority, and its year of establishment is 1997. So it is constituted under Section 3, Subsection 3 of the Environmental Protection Act that we have discussed earlier in the year 1986, and its key objective is to regulate, manage and control groundwater development and extraction across India, issuing guidelines for industrial, commercial and infrastructural projects. Number second, we have the National Water Policy, and the year of formulation is 2012, and it is being formulated by the Ministry of Water Resources, which is being now integrated under the Ministry of Jal Shakti. So it coming to its key objective, it prioritizes drinking water as the primary allocation preference above all other uses, and therefore promotes the volumetric pricing of water to curb wastage and enhance supply efficiency. Number third, we have the Pradhan Mantri Krishi Sinchai Yojana, that is the year of 2015. So it is an umbrella scheme combining three erstwhile program. Number one is the Accelerated Irrigation Benefit Program. Number two is the Integrated Watershed Management Program. And number third is the On-Farm Water Management Program. So its vision is to har khet ko pani, and its objective is to per drop more crop through micro irrigation system. And number 4, we have the Jal Shakti Abhiyan of 2019. So it is a time-bound mission mode water conservation campaign that was being focused on water stress districts. So its key objective was to promote rainwater harvesting, groundwater recharge, and traditional water body restoration under the popular campaign theme Catch the Rain Where It Falls When It Falls. That is being totally linked to the rainwater harvesting. And number 5, we have the Jal Jeevan Mission of 2019, which is being the nodal ministry of this particular scheme is Ministry of Jal Shakti, and its key target is to provide functional household tap connection offering 55 liters per capita per day to all rural households. And number 6, that is the Atal Bhujal Yojana of 2019. So it is a central sector scheme co-founded on a 50-50 basis by the government of India and the World Bank. So its key objective is to facilitate community-led sustainable groundwater management in priority water stressed states like the Gujarat, Haryana, Karnataka, Madhya Pradesh, Maharashtra, Rajasthan, and UP. Next, we will go to the next slide very quickly. That is the breakdown of renewable and non-renewable energy. We will be seeing about that. So in renewable energy, we can see there is the coal classification. On the left side, there is the non-renewable energy. On the right side, there is the renewable energy. So if we go into the detailed breakdown of non-renewable energy, we can see the coal classification. So it is mostly ranked by carbon content and heating value. Number 1 is anthracite, that is the highest quality coal, hard, black, and with low smoke emission and high calorific value, and it is rare in India but mostly found in Jammu and Kashmir. Number 2 is the bituminous carbon, that is the most common commercial carbon in India, and it is being used extensively in metallurgical processes like the coking coal and thermal power generation. Number 3 is the lignite, which is also known as the brown coal, and it features the high moisture content, and its major deposits located in Tamil Nadu. And number 4, we have the peat, and that is the initial stage of coal formation with high moisture and ash content, yielding low heating efficiency. So you have to remember this detailed breakdown of the coal in order to know their capacity of the carbon content. And then we have the Indian coal deposits, that is the Gondwana coal fields, and it is the older geological formation which is located in river valleys like the Damodar, Mahanadi, and Godavari. And if you look at the tertiary coal fields, there is the younger deposits mostly found in the northeast India, specifically Assam, Meghalaya, and Nagaland. Next, we have the petroleum and natural gas, and its major reserves as the offshore fields like the Bombay High, along with onshore fields like Gujarat, Ankleshwar, and Assam. That is, in Assam, there is the oldest operational oil well, which is known as the Digboi Oil Reserve. And then we have the clean alternatives, that is the natural gas, which represents the cleanest burning fossil fuel. And key non-conventional hydrocarbon sources include coal bed methane and shale gas. Number 3, we have the nuclear energy. So it uses the heavy radioactive elements like the uranium and thorium to generate electricity through controlled nuclear fission. And now we will be seeing at the breakdown of the renewable energy, which is there in the right side of the slide. Number 1 is the solar energy. So you have to remember that the photovoltaic. Photovoltaic is a term which is used to define the conversion of sunlight directly into electricity using semiconductor materials. That is photovoltaic. Next, we have the concentrated solar power, which uses mirrors to concentrate solar heat to drive into a conventional steam turbine. And next, we have to remember one of the key alliance that is being related to the solar energy, that is the International Solar Alliance. It was being co-founded by India and France in 2015 at the COP21, which was held in Paris, and its headquarters is at Gurugram, India. Number B, we have the wind energy. So it harnesses the kinetic energy from wind via wind turbines to convert it to mechanical as well as into electrical energy as well. Number 3, we have the hydroelectric power. So here we can divide into large hydro, small hydro, mini and micro hydro, and pump storage hydro. Number D, we have the biomass and bioenergy, which is being derived from the organic matter such as the wood, crop residues, animal waste to produce heat, power, and liquid biofuels. And number E, we have the geothermal and ocean energy. So geothermal energy is the one that harnesses internal heat from within the earth for power generation and space heating. Secondly, we have the energy, ocean energy, which taps into ocean tides, waves, ocean thermal energy conservation, and ocean currents as well. So quickly, we will be moving into the next slide, which is related to about the important terminologies in disaster management. Number one is hazard, number second is vulnerability, and number third is disaster. You have to remember the terms. So what is a hazard? It is a dangerous physical condition, natural phenomenon, or human activity that holds the potential to cause loss of life, injury, property damage, socio-economic disruption, or environmental degradation. Secondly, we have, for example, in case of hazard, we can take about the examples of active volcano or the seismic fault line or a cyclone as well. Secondly, we have the term vulnerability. So it is refers to the condition determined by physical, social, economic, and environmental factors or processes that actually increases the susceptibility of a community or system to the impacts of hazard. So here you can take the example of the poorly constructed houses built along the steep slope lines, lack of early warning system, poverty, or living in low-lying coastal floodplains. That is being referred to as the vulnerability. And thirdly, we have the important term that is the disaster. So it refers to a serious disruption of the functioning of a community or society involving widespread human, material, economic, or environmental losses that exceeds the ability of the affected community to cope using its own resources. So here you can take the key characteristics then. A hazard only becomes a disaster only when it interacts with a vulnerable community and causes damage beyond local coping capacity. So with this particular line, I have clearly showed the interrelationship among the three terminologies. Next, we'll move on to the next slide, which is the classification of natural hazards. So I will be discussing on that. So here we can see that there are three categories. Number one is the geophysical or the geological hazards. Number one is definitely the earthquake. So we all know that Richter scale is used to measure the magnitude, while Marshall scale measures the intensity. So you have to remember the particular tools and their purposes. So if you go on to remember the seismic zones in India, so it is primarily divided into four seismic zones according to Bureau of Indian Standards. So you have to remember all the zones along with their damage intensity along with the particular states that are vulnerable to this particular earthquake. So secondly, we have the tsunami. So it is the harbor wave generally predominant by the subduction zone undersea earthquake that we all know. That is the underwater earthquake is also known as the tsunami. So if we go on to remember that the catastrophic 26 December 2004 Indian Ocean tsunami, so it directly led to the establishment of the Indian Tsunami Early Warning Center, which is being operated in Hyderabad. Thirdly, we have the volcanoes and the landslides. So it is mostly happens in the Barren Island located in the Andaman Sea, hosting India's only active volcano is present there. And number B, we have the hydrometeorological hazards. Here comes the first one is the cyclone. So tropical cyclones that is formed over warm ocean surface water. Then we have to remember the Coriolis effect. So what is Coriolis effect? It rotates the counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Secondly, we have the flood and flash flood. So it is being triggered by a land uses changes, unplanned urbanization, loss of natural vegetation, and inadequate drainage. Number third is the drought. So it is, we all know that is the lack of water in a particular region is also known as the drought. So you have to remember the particular types of drought, that is the meteorological drought, hydrological drought, and agricultural drought as well. And number third category is based on atmospheric or climatological hazard. Number one is the heat wave and the cold wave. So it is being defined by the IMD, that is the Indian Meteorological Department. So you have to remember that. And number second, we have the wildfire or the forest fire. So which is being triggered by prolonged dry spells and sometimes the high atmospheric temperatures. Mostly we have come across such examples in Uttarakhand and Northeast India as well. So we will move on to the next slide, which is related to the international agreements, protocols, and conventions. So you are here, you have to remember again it chronologically, and you have to remember its key purpose. So firstly, we will be going around the early foundation, and number one definitely comes the Stockholm Conference of 1972. So this is the UN Conference on the Human Environment, and it led to the birth of the United Nations Environment Program. So you have to remember the key characteristics, and the celebration of June 5th as the World Environment Day is definitely related to this 1972 Stockholm Conference. So you have to remember that. Number 1971, I have misplaced in 1971 is the Ramsar Convention of Wetlands. So it is being adopted in Ramsar, which is a place in Iran, and therefore we come to know it as the Ramsar site. So it focuses on the conservation and wise use of wetlands of international importance. And number third, we have the CITES, that is CITES. You have to remember that it is the Convention of International Trade in Endangered Species of Wild Flora and Fauna, and regulates the international trade to ensure species survival. Then we have the Vienna Convention. So here Vienna Convention is very much related to the ozone layer. So in terms of ozone layer, you have to remember number one is the Vienna Convention, number second is the Montreal Protocol, and number third is the Basel Convention. These three protection are related to the ozone layer. So in Vienna Convention is the framework agreement established for the protection of the stratospheric ozone layer. Montreal Protocol, which is in 1987, which is the landmark treaty signed to phase out ozone depleting substances such as the chlorofluorocarbon, and it is also known as the most successful international treaty. That is the Montreal Protocol of 1987. And 1989, we have the Basel Convention, which regulates the transboundary movement and disposal of hazardous wastes and chemicals. Next, these are categorized into Art Summit and key conventions starting from 1990s. And number one is definitely the 1992, that is the Rio Art Summit. So it is the landmark summit producing three major legally binding convention. Number one is the UNFCCC. Number second is the CBD, that is the Convention on Biological Diversity, and number third is the UNCCD along with Agenda 21. Number second is the 1997 of Kyoto Protocol, which were adopted in the UNFCCC, and it's committed industrialized nation to binding emission reduction target for 6 major greenhouse gases based on common but differentiate responsibilities that we have already come together in our previous class as well. Next, we have the Cartagena Protocol of 2000. It is a supplementary agreement to the CBD governing biosafety regarding living modified organism. In 2001, we have the Stockholm Convention, which focuses on eliminating or restricting the production and use of persistent organic pollutants like DDT and PCB. And next we have the 2010 Nagoya Protocol, and it is also a supplementary agreement under the CBD focusing on access and benefit sharing of genetic resources. And in 2013, we have the Minamata Convention, and it is designed to protect human health and the environment from anthropogenic emissions of mercury. So you have to remember that. And next we have the 2050 Paris Agreement, which is also known as the COP21. So it set the goal to limit the global warming below 2% that we have already discussed in our previous class. And it is also related to the employment of sustainable development as well, because we know that the duration of sustainable development is from 2016 to 2030. And it was in 2015 that the preceding, that is the Millennial Development Goals, and its term was ended. And in 2022, we have the Kunming Montreal Global Biodiversity Framework. So it was being adopted at the COP15, and it set the landmark of 30 by 30 target to protect 30% of Earth's land and oceans by 2030. So in the last slide, we'll be seeing about the very recently discussed topic about Panchamrit, which is known as the 5 nectars. So it is India's climate commitment that form one of the most frequently examined modern policy topics in UGC NET paper 1. So coming to its announcement, it was being unveiled by Prime Minister Narendra Modi at the COP26, which was held in Glasgow, United Kingdom in November 2021. It's coming to its core vision. It represents India's 5-point climate action strategy to achieve long-term sustainability while balancing national economic growth. And it was being formally integrated into India's updated nationally determined contribution under the Paris Agreement approved by the Union Cabinet in August 2002. So the 5 commitments here I have discussed. So number 1 is non-fossil fuel capacity, that is Horizon 2030. So its goal is to reach 500 gigawatt of non-fossil fuel energy capacity by 2030. Secondly, we have the renewable energy share. We have to meet 50% of total energy requirement from renewable energy sources by 2030. Next, we have the carbon emission reduction by 2030, where you have to reduce the total projected carbon emission by 1 billion tons between now and 2030. Fourth, we have the carbon intensity of GDP, and here the main goal is to reduce the emissions intensity of GDP by 40% by 2030 compared to 2005 levels. And number fifth, and the most important one, is the net zero target, and its horizon is limited to 2070, and its goal is to achieve net zero carbon emissions by the year 2070.